like to do work and get your work done, you'll be fine.
And the black box.
So, let's take a look at an example.
I was going to, but you were too far away.
Let's take a look at this example here.
This is what we did.
Right? We didn't do this one yet.
We did square.
Yeah.
Now,
Could it be the same rules?
here's what I would like to do. I'm not going to tell you what U is here. I'm not going to tell you what to do to break this up. I want to take some suggestions and see what happens with our problem. Okay? And this is what you need to be doing your homework. And I'm going to explain to you exactly when you can just stop and say it's not going to work and start over. Remember we talked about that? If it doesn't work, you start the process over again. So what we're going to do is figure out exactly how that works. Okay? Suggestion.
We could break it up into cos squared times cosine of x. Go back to
I agree. That's
then make crap. Then we make like what is it u?
Really? That's what we're going to make?
Yeah. Oh yes. No.
You agreed to it though.
But like some people.
Can you give me a reason why you're saying this right now, please?
Saying this because we don't know what cos cubed is, but
We don't know the integral of cos cubed. Good. To start. We don't know what the integral is.
but
I can start by calling it u, but there's nothing for it to cancel with. So I can't just call that u. So, Christian, what was your suggestion?
to break it up.
Into what?
Split it up. So it's cos squared times cos.
Why? What does that do for me?
Oh,
I'll do that. I mean, I don't mind doing that, but I need to know why this works before I actually do
I
it.
don't know how that's gonna help us. Though.
Okay, so that's a suggestion.
Because you know the integral cos x.
But there's a time, so I can't do it still.
And you can make one of the u now.
And I didn't want to split it up into 3 because what's the point of having 3 cos of x? Like, I mean,
Why not?
that means wouldn't that mean you have to take 2 variables? Have 2 variables then?
If you break it into cos, 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 you're right. It doesn't make sense.
It's not gonna help at all.
Because when you if you call one of them u, then they all become u. And it really doesn't do much for me at all. So you're right, I wouldn't break it into 3. 2 is a good start. It's a good start. But what would you call u now? That's my question.
cos x.
Cos x? Just the plain cos?
No, like the middle part.
Which one? Cos x or cos squared x?
Cos x.
You want to call cos x u? Is that what everybody wants to do?
yes.
Yeah.
We got it, guys. I'm trying to have you show how you can experiment with it.
Yeah,
So let's say u equals
I feel like it's going to cancel out like the
cos x. All right, so du dx is negative sine x.
So we're going along.
Okay, let's try this one. If it doesn't work, we'll stop and come back. I'm just trying it. I don't even know if it's going to work or not. Okay? Now, if u is cos x, and we plug back in, okay, so we solve for dx over here, so we solve for dx.
So what do you want? Times b.
So again, there's my important part there, and there's my other important part. Remember, every single time, these are the parts that you're going to substitute in at the end. Those are the important parts. So here, I'm trying to find if I want to see plugging this back in.
Your u's and your y's, I think.
My u's and there's no y's. Sorry, there are no y's here at all. They're all u's. Sorry.
I mean a y,
They're all supposed to be u's.
right?
That just proves the whole handwriting thing as the day goes on, it just gets worse.
Anyway, so we plug it back in.
What can I do now?
We can plug it back in.
We have to plug back in. That's the next step.
Wait,
Oh, you can
whoa,
change-
whoa, whoa, whoa. Can we just change stuff?
Whoa, time out. Before I start changing stuff, though, I want to make sure that I'm clear. If I plug back in, what's going to happen? That's just in case we didn't change anything first.
Yeah.
If I plug back in, this becomes u squared times u. Again, isn't cosine of x just u?
Yes.
So this is really just u squared. It's cosine squared. And cosine is u. And this is really just u. So I end up getting u cubed times this thing, which doesn't help me
No.
because it doesn't cancel. So you know what? We might stop and say maybe we can make a change. God bless you. Carrie, what kind of a change can I make here? God bless you. Pythagorean identity. What's cosine squared x, Carrie?
1 minus sine squared.
1 minus sine squared x. Well, that's closer. He's closer still. It's still not right because we can see it's not going to work still because of the sign there. But we have the right idea. Okay, we have the right idea. Let's take a look here. I'm going to call this u. I'm going to write this as du over negative sine x. I might have to do a little work to make this work here. What do I have to do here?
Get the sign.
Put the sign on the outside, or make the sign x on the outside. So we should be.
Guys, see how these are functions of x? This process never works unless all of your x's happen to cancel. Take a look here. This is singular sine of x. This is sine squared x. I can't just cancel these expressions.
No, you should.
You see what I'm saying? Remember, if your x's don't cancel, this doesn't work. So we still have to do something else.
Yeah.
Can we what? I'm sorry?
Okay, distribute to you.
What do you mean? Distributed to both these terms?
Yeah.
You can do that. You can always do that. There's nothing wrong with it, but
be one side
you're still going to have a sine of x somewhere. This is going to end up being, remember, this is divided by sine of x really here. That's what that says. So if I divide both these by sine of x, I'm going to be left with 1 over sine x here, and then just sine x here. But everything is u. I don't want x's. So unless the x's go away, I can't actually do this. So we go back to the drawing board. We start over. It didn't work this way. No big deal. But Kerry, I liked your idea of a Pythagorean identity. Maybe that's a good choice. So let's go ahead. Go back to our Pythagorean identity. Or let's go back to this line. We'll leave it like Christian said to start with. We started again with just a cosine squared times cosine of x.
Wait.
Now, let's start by putting in a Pythagorean identity to begin.
That's not. Could you change? Yeah, I know.
Okay,
That's why I was waiting for you to stop talking. Could you No. I was still gonna say. Never mind. I was thinking.
Could you say the 1 minus sine squared x?
Yeah, why not? Why can't we do 1 minus sine squared x as u? Because clearly the cosine didn't work, right? No matter what. We tried the
I
cosine,
see.
we tried it here, then we tried it with the trig identity, so the cosine being u didn't work. So don't ever try that one again for this problem. Again, if it doesn't work in this case, it's not going to work again. So let's try the other one now. This might work. Let's see.
But I was thinking.
Yeah.
Okay, what's the derivative of 1?
0.
0, so that doesn't matter. So du dx turns out to be, what's the derivative of sine?
Cosine.
Okay, but be careful here. What kind of a problem is this, guys?
Wait, change.
It's a chain. This is really, again, see the sine squared x? You need to think of it like this. Like that. Because now it's a product, a power rule with a chain rule inside. So the power rule will tell me that it becomes negative 2, repeat the function, times the derivative of the inside.
Cosine.
What's the derivative of the inside?
Cosine.
So that's what the derivative turns out to be for this one. You see what I'm saying, people? Okay, again, that's what the derivative turns out to be.
Is it not
So-
negative cos?
No.
Derivative of
This is
sine, the negative comes out here, Ken. The negative from here, that's where that comes in. I bring the 2 down in front,
No, I
so
know
I
what
have
you did.
negative
I
2.
know what you did.
Now, solving for du, or solving for dx rather, sorry. Isn't that what I get when I solve for dx there? Now, look at this problem here. If that's the value of dx, what can I then possibly do after that?
Cross out, close.
No.
Cross out the cos.
Swap GX.
Let's take a look. If we plug it back in here, if I go ahead and take this value now, I plug that in for dx, I take my u value and I represent that with a u. I get the integral of u times the cosine of x times whatever this is. Everybody see that so far? I just plugged back in. That's all I did. Does that work?
No.
But it works better than the last time. Would you agree with that?
Yeah.
Because why, at least?
So you can cancel out now.
At least the cosines cancel, but the problem is I still got that sine of x down there. So this doesn't work either. Are we clear on that? Again, it looks like it might work at first, but because of the fact that the cosine is the only one that cancels here, since those are the only ones that cancel, it's not going to work. So we go back and try another method.
What's that thing called? You put the 1 minus sine squared x?
Pythagorean identity.
Oh, okay, we got it.
And what?
I was gonna say you can go ahead back to the top of the but you can't because it's not squared, it's cubed.
The original
1 minus sine squared.
cos cube.
Say it one more time.
I was thinking you could plug the 1 minus sine squared x into the cos cube x, but you can't because it's cubed.
Because it's cubed, yeah. That's why it only goes into the square. What's another possible thing to work with here. Could we try cotan? Explain what you mean.
Cosine squared. Let's replace the cosine square x with cosine square x times or cosecant.
1 over sine? No, it would be times sine. Times sine, you'd be saying. You could replace that with cotan squared times sine squared. But I don't think that's going to help us either. Because then you have the cotan and the sine squared. Sine squared, you get sine cosine. It's a tricky one, guys. It's a very tricky one. Let's try. Look at the setup that we had here. Let's continue with this line right here and look at the setup. We tried cosine of x, right? And that didn't work. We tried 1 minus sine squared of x, and that didn't work. What if I just called this u instead?
You can do that?
Because then, watch, what would happen? I would end up with 1 minus u. I can integrate that as long as everything else cancels. Right? You can integrate 1 minus u. You can integrate 2 minus u, 3 minus
I'd rather
u.
need a whole argument.
It doesn't have to be the whole thing. And we put the word argument before, so I understand where that could be a little misleading. But it could be part of it. Let's just try and see what happens here. Let's say instead, again, let's just go to the next line and do this. So we're going to continue this green line right here. And let's say in this case, and try this on your own please, see what you get. Let u equal just sine squared x. Try that one. Just do positive for now. Just that one part. One part. I'm kind of goading you guys in a direction, and I'll explain why I'm doing this. It's not just random, okay? There's a reason we're trying all these ways, and you'll see as they pick up along, it gets a little easier. So again, let u equal sine squared x here. Tell me what you get when you do du dx.
I'm gonna.
Alright.
Yeah, I am going to.
Again, see what you get when you take the derivative of sine squared x. See if that helps you. If you need help, please ask. I want you to try this on your own.
The chain rule. After post X. Negative post.
What does du dx become? That's what you should have gotten when you take it, right? Okay. The 2, it comes out in front as a power rule. You take the you
bring it down.
sorry, you bring it down. You reduce this by 1, and then you multiply by the derivative of the inside, which is cosine. Solving for dx, we get du over 2 sine x cosine x. Okay? Now, if I plug back in, though, here's what I'm going to have.
You're right, that y. Du, y.
That's how du.
You mean you, not y.
Where am I writing a y?
No,
Here?
no,
No, it's
that-
not
that-
green.
Well, that one.
Here?
No.
Other
all of
one.
them.
Next one.
No,
Down,
that's
down,
right.
right, right, right.
Oh gosh, that was actually an x by mistake. Let's put in du. That was a terrible looking x. So does this one work?
No.
What are we noticing, guys? The ones that come closer, though. The cosines cancel, don't they? But it's that sine that's killing me. Where's that sine coming from? Where is this sine coming from right now?
The chain rule.
From the fact that it's sine squared, right? When I take the derivative of sine squared, if I just had a sine up here, what would the derivative be?
Close.
Just cos, wouldn't it?
Yeah.
But I keep getting this sine, and it keeps bothering me. So maybe instead of letting u equal sine squared, what should I let u equal then? Just sine. Again, let me start over. When I take the derivative of sine squared, this is what I get. And I keep ended up with this sine left over, which I don't want. To not have that sine, I need this to be just regular sine. Because the derivative of regular sine just gives me cosine. And then this won't appear down there. So let's do this one again. Integral Again, it's 1 minus sine squared x
Yeah, they can put,
cosine x dx. And we're going to do the same one again now. And now we're going to say, let u equal just sine of x. Now try it this way, please. This one's a little bit tougher for math, but it should work here. It should work here. And no, it will work as long as you do it correctly. We should all be at that point, maybe?
Yeah.
Okay, derivative of sine is just cosine.
yeah, you get one, it's like 1 minus u squared.
So, let's go back in here now. Now it's not 1 minus u like it was before.
1 minus.
U what, Kenny?
Square.
Because again, u is sine of x, but we have sine of x times sine of x, really. So it's really 1 minus u squared. Well, this one is still cosine x, but what do you notice?
They cancel out.
Hallelujah. And now you notice everything is in terms of u. And again, it's not an easy process, and that's why I keep emphasizing this. It's not just about like, oh, I know how to do this process every time. A lot of it is trial and error until you pick up on patterns. And the pattern I was wanting you to pick up on was that you kept having that sign left over. That sign in the denominator was constantly left over. How do I get rid of it? Well, if I don't use u as sine squared, but u as just sine, now it's just cosine. So there's no longer a sign down here. So there's no longer a sign with this one that was left over every time. Okay, at this point in time now, what's the integral going to be?
U minus u.
Good, the integral of 1 is just u. The integral of this is going to be u cubed over 3 plus c. And now just plug in for u. Just plug in your sine of x back in for u.
Sine of u, you mean, right?
Am I going to move a third to the front? No, I'm not, because 1/3 to the front would mean, Karen, that I had like a 3 down here. And that would be a 1/3 out front. This 3 comes from the fact that it's integrating u squared. If you take the integral of u squared, it's u cubed over 3. That 3 only pertains to that part of the integral. So here now I want to plug in back for u. U is equal to sine of x. So this is just sine of x.
Minus sine cube x. Over 3 plus
And that's the integral, which is nasty. It's not good looking at all. Go back to the very beginning of the problem. We started with cosine cubed x, right? Wasn't that the integral we were doing? Cosine cubed x? You would never think that it would come out to be exactly this. Okay, so a lot of these problems, the answers are not necessarily your first bet or your first choice. Okay, your first choice or your first bet here. Try one on your own now. And I want you to try, if it doesn't work, try another part. If that doesn't work, try another one. You have to think about what you could be. Again, I keep telling you guys this, and Edgar noticed this the other day. He told me, all this stuff is tricked. Okay, it is very rare that it's not a trig substitution. So just so you have an idea of this. Now, please don't let theta confuse you. Theta is the same thing as x. Okay, so when you do u now, it's not du dx, but it's du d theta. Okay, because everything's in terms of theta and not x. Look at this one. They're times, by the way. I don't show it. They are times. Look through this one, and please make sure that for this problem, you try several things. You could start with trig substitutions. You could start by calling one of those two things u. It's up to you to start what you want to try here. And not one way is always correct. There are more than one way to do some of these problems. That's another thing to note. So pick what you want u to be out of those two to start. I would recommend starting that way. Whenever it's a product of two things, always start by saying, could I make one of them u and will it work? If it's not a product, like the last one where it's cosine cubed, maybe then we want to start looking at, trig identities to substitute in. You could put a trig identity here, that's fine, but I'm not telling you have to. You might need to look back at your derivative tables for trig. So to know what derivative of tan, secant squared, and all that stuff is. Derivative of secant, whatever it is in this case. Again, many ways to do this problem.
It's always one of them. It's a holding fee here, you know, right? $10 an hour. You've been here for like 4 hours now. Right. Well, you better let me win that competition tomorrow or Thursday. Or do you get paid?
He laughs because it's true.
You get paid in pies.
Pies are more than dollars, actually, right? So I'd rather pay pies. $3.14 every day. Does this count? Like, this only inside here it has to
Yes.
correct. And that's what you're
So this is not.
Hey, you have a good idea here, right? See how you're gonna have a secant squared there?
Like, so that can work?
But just take a look, that's secant squared, isn't it? You can't do that. So why do we not change it? See what that really is, secant squared? Oh, then keep that wood, they're canceled. You did the right thing. There's no need to change that, you can identify. There's no need, right? So keep that the way it was, and then you have the secant square down there.
No, but you said it's derivative.
No, what's secant
Christian,
squared?
if two things are ever derivatives of each other, and they're there, you don't have to do much at all.
Okay, I saw that one.
I was waiting for you guys to pick up. That's one of the other things you notice.
You do here, 1 over. Here's 1 over cos.
So you're gonna do it over the coast?
Good, that's squared, huh?
Yeah.
You're right.
That's
That's a theta, right?
But it's secant squared.
Did you notice the other product? So it's those products have to be derivatives of each other. So the derivative tangent is just secant squared, right? Traditionally, one of them will be u, the one that you're gonna take the derivative of to get the other thing. And now it's, that's an easy way to always think about it.
Same thing goes for sine and cosine.
No, you said the derivative of tan is secant squared?
Yeah, so that helps, doesn't it?
Yeah.
Because you know you're gonna have to get rid of the tan, you're gonna have to get rid of the secant squared anyway.
I know it's a trig identity, but I mean, I'm trying to make it like those trig functions.
Yeah, I gotta look back at my notes again.
Did you get anything, Kevin?
No, not yet. I'm still trying to figure out what to use for you. Because I don't know if I should even try to remove secant squared. Because I was thinking about,
I was gonna separate them.
I was trying to make it sine q over cos q. Huh?
Derivative of tan is secant squared.
Okay, then.
And that's minus 4, that's plus 4.
Then use tan as u.
You do too much work.
Yeah, you should usually cancel.
I was thinking about it at the beginning, but I don't know.
All right, many of you noticed right away that for a problem like this, what you want to look at is that the fact that the two things being multiplied are derivatives of each other. What is the derivative of tangent?
Secant squared.
Secant squared. Isn't that here also? Whenever you have the two functions and their derivatives, so if this was like cosine and this was sine, you would just use one of them as u. And we did that in the beginning of class, today, during the day. So here, just let u equal tangent theta. Because when you take its derivative, you're going to get secant squared theta, which can then possibly cancel here. So whenever you have two things that are derivatives of each other, you start by listing the one that is the derivative you're going to take to get the other one. Again, to get the other one. So here, you say du d theta equals secant squared theta. Switch the spots. We'll say that du over secant squared theta equals d theta. Again, it's like dx, d theta. Now I take this and I plug it in right there. And I make the u equal to tan theta. So now I've got the integral of u secant squared theta. This is going to become du over secant squared theta. And what happens to those? They cancel. And you're pretty much doing the integral of u
So that's usually
over,
and 2.
2. Plus C.
and u was listed as tangent, right?
Yeah.
Why
do you square
that?
Because of.
Integral.
2 plus C.
Erase it to 1.
That's
Oh,
fine.
yeah, integral. I keep forgetting that part. Yeah.
Okay, again, we defined in the beginning u to be tangent theta. If u is tan theta, du d theta is secant squared theta. We solve for d theta, plug in, and see that they do end up canceling.
Oh, an hour now.
What kind of question would
Yeah,
be on that eight?
Multiple choice?
Probably multiple choice. If it's in a part 2, it'd be a sub-part of it. Okay?
Fine. C.
And on the exam, look for things that are derivatives of each other like this. Or look for trig identities.
Did they ask you to find C?
If they give you a particular
Can we make?
Okay?
Oh, they asked you to find C?
Sure. They can give you initial condition and say that, you know, what was the function of? We don't have even a function here. Say it was f of theta. If they say f of 0 equals 5, you know, you plug in the 0, set it equal to 5, solve for C, same way we did. Or they might give you limits on the top and bottom. Just do your limits of this now instead of the C. Just evaluate it from one limit to the other.
Yeah.
Okay, we'll do that with the next one. We'll put limits in there.
Yeah, I don't even look at it.
I am preparing, I'm giving you guys a better future.
It's your family.
No.
Aiden.
Should you try to make things like derivatives just for now? Like to change,
Make it cancel each other.
yeah. To change like the function given to make it, like the derivative, like.
If we realize that if we change it in a certain fashion, the original function, to a way that
You have
they're
two
opposite-
derivatives?
They're opposite of each other.
Derivative-wise opposite?
Yeah.
Sure. It's a good way to think about it, yeah. Absolutely. And that's where changing cosine to 1 minus sine squared came in before. Remember, you actually were the one that said it? That's where that would come in.
Really, I hated this bag. I hated they were all grape and apple. God, I hate grape and apple.
You get a break, yeah.
You can get a grape. Thing is that people ask me for so much that I have to get it to them. Because you guys don't consider the price. Damn that. What, for Snickers?
No, yeah, I pay that girl.
All right, let's try another one now.
I don't be buying like that. Man, I ain't trying, stop her hospital.
Oh, the BGP hustle and other stuff.
What you doing?
It'll tell you about the weekend.
All right. For a problem like this, please, people, please, there's no trig. So either the top is u, the bottom is u, or this portion right here might be u. That's pretty much your only choices. You've got 3 choices. U could be x, u could be x squared, or u could be x squared minus 4. That's it. There's nothing else to choose from.
I would rather use X.
Everybody see that? Okay? Now, the only other option would be to factor this in x plus 2x minus 2 and call one of those as u. So it's the same thing as this, really, you know?
Then you get 2x.
Okay.
So I mean, if you automatically just use x, you get you get 1. You can derivative of that. So you just
Kenny's exactly right what he's saying. Listen, say that a little louder. If we chose x, what would the derivative then be?
1.
1. So if we let u equal x, this would be a u here, and you'd get over 1, which is not going to cancel this. So this is clearly not our choice. So we then have to say which of these two might work.
The x squared is the best choice.
You
The
couldn't,
derivatives are both the same, yes.
Mr.
The
House,
derivatives are both the same.
now you couldn't use the, I don't know what it's called, but like, you couldn't use the factor, one of the factors of x.
That's what I just said to Carrie. I was like, you could factor this into x plus 2x minus 2 and try and call one of those u's. I said it to you, actually. But the thing is, if you make this x plus 2 and x minus 2, and you call x plus 2 u, it's still going to be 1 as a derivative, right? The derivative of x plus 2 is still 1. So it's still not going to cancel what you needed to cancel. That's the issue you're going to have there. Okay? So you're going to choose one of these two. It doesn't matter which one you want to choose to try. Try one of them.
X squared.
X squared?
Uh-huh.
You want to try x squared? Is that correct?
I got a better answer. What are you doing? Yeah, I'm not gonna
Solving this problem.
All right, so that's what we get from doing that then. So we've got
Wait, so you can put ln in the end?
Well, let's see if we get that.
The x cancels out, it's 1 over u minus 1.
No, because x squared.
So, in this problem,
Over x.
we end up with, see the 2x and the x, what happens to them?
Cancel.
They cancel with each other. Because this cancels with this here, you end up, yes, you end up with an ln function, but remember here,
2 ln of
it's not just 1 over u, it's 1 over u minus 4. It's 1 over u minus 4, not just 1 over u. Everybody see that? Okay? So again, the integral of that can be the ln, but it's the ln of this whole thing. This whole thing. Okay, so when you integrate this, your answer is not just ln of u. The answer is the ln of u minus 4, like that.
Now, what do you do to?
Okay, now this 2, bring it out front as a 1/2, so simply put a 1/2 in front of here. Okay, move the 2 in front, make it a 1/2. And you have the plus c. Now, notice though, if you had chosen the other way, you get the same answer actually. Because now I have to plug back in for u, don't I? U is x squared, isn't it? So here, I'm going to have 1/2 times the ln of x squared minus 4 plus c. But why am I putting plus c? Because I'm an idiot. It's not plus c. What should I put on this side now? What's the integral limits, guys?
1.
Yeah.
Remember this? When it's a definite integral, we got to put the limits on the end. So no plus c. At this,
Why? Okay, no, I was saying why did you do both? Because, yeah.
you see where this came from right here? It was u minus 4, but u was given as x squared in the beginning. If you had chosen u to be x squared minus 4, you get the same exact answer. Okay, there's no difference because you would plug it back in for u, the whole thing. Now evaluate. Notice here, for this kind of a problem, isn't that absolute value sign pretty important now?
Yeah.
Because before the absolute value sign, this would have been a negative, wouldn't it? Plug in a 1 for x, you get 1 minus 4, which is negative 3. So remember that absolute value sign. That's why today I made sure to mention that to you. Okay, because it does come into play sometimes.
So why do we plug in? Why do we take out the x if we will put it back in?
Why do we take out the what?
The x. Why do we replace the x with u if in the end we're just gonna put x back in?
Because the only way we can integrate is if everything's in x's or if everything's in u's. But in the beginning, everything was in x's and we couldn't integrate. It was a weird looking integrand. But now look at the integrand. Once you get rid of these x's and you put the u back in, now it's a u and du. So we can then integrate the u and then put the x back in. Because in the beginning, you couldn't use the x's.
Right.
You tell me, what's the integral of that? See what I'm saying? You don't know what it is. Unless you, I'm sorry, can you do that in your head?
Is it?
It's not natural log. Because there's no integral of this. There's no way to do it. You see what I'm saying though? Like, try and do this in your head. Try and figure out what the integral is of that. If you can figure that out, then you don't use substitution. But you can't. There's no way to do it. Okay? It's not impossible. I mean, this is a quotient. How do you integrate a quotient? There's no like anti-quotient rule. You know what I mean? You can't like do the quotient rule for integrals. It doesn't exist. That's where use substitution comes about. Plugging in now. Plug in, please. Let's see what we get here.
You repeat the 1/2 twice?
You could repeat it twice, or you just leave it on that.
And then put it on.
0 is 1, or 1 is, I have no idea.
So you could have left the 1/2 on the outside if you put major parentheses around the LNs, but I'm going to put the 1/2 in both. Doesn't matter. Okay, if you want to, just to show you, you could have gotten rid of that. Put a parentheses here. Woo. Put a parentheses here, and then a major parentheses here, and then you don't need the 1/2 in both terms. It's the same thing. Okay, pick whichever way you want to do it. Doesn't matter. ln of 0 squared minus 4. Okay, again, remember, you put the upper limit in first, you then put the lower limit in, subtract those two things, but the 1/2 was outside the whole thing here. So if you want the 1/2 there, you got to make sure you put it on the outside, or put it 1/2 in both spots. So distribute. What do you end up getting here?
Oh, -3.
1/2 ln of just 3, because it's the absolute value of -3,
Minus,
minus ln of just 4 in this case.
which
Okay?
No, because basic.
E is the base. E to what power gives me 4? What I can do is write it like this.
I hate it. Yeah,
Remember, subtraction with logs means division with the argument. Remember from Algebra 2, if you're dividing two things inside the argument of a log, it really means subtracting them individually. So this would be the multiple choice answer. Or, it might even look like this. This is going to be crazy. Oh, wow. Because what does a 1/2 in the front really mean? It really means an exponent. Remember that?
Oh, wow.
Yeah.
Remember the number in the front really means an exponent? What's a 1/2 as an exponent, though?
Radical.
So this is another way to write your answer. So think back to multiple choice, how hard they become because of these rules. Probably this way. This is the toughest way right here. So there's a good chance that would be the answer for this one. They're not going to ever put both because they're both correct. Okay? Again,
Correct.
all three of these are actually correct, but which one is the most simplified would actually be the third one I wrote here. Okay? But they're all correct mathematically. But the hard part is, hey, this is a non-calculator question for sure. Did we even touch a calculator? So if you don't know that this is the same as this, you can't even like sit there and try the numbers to see what decimals you get for each choice and try and like match them up. It won't work because you don't have a calculator for this part. Okay, so please make sure you understand this. Subtraction means division. A coefficient means an exponent. An exponent of 1/2 really means square root. Okay, really means square root. How long is what? They give you for this question. How much time do they give you? Between 2 and 3 minutes. Every question. The non-calculator are traditionally 2 minutes approximately. Just by looking at the old test, that's what I get. 2 minutes approximately. The calculator ones are 3 minutes. Because you have to use your calculator and do a little more work. They expect you to be doing that. It takes time to enter it. But just so you know. Okay?
I think it also takes time to guess too.
Yes. What do you mean if you fail it? What do you consider failing it?
Not passing?
The 1 and the 2 is considered not passing. Yes,
Okay,
it
so
is
that's
considered
better.
that. You don't fail the class, no. Okay? I'm going to talk about this, guys. If we want to do this for the end of the year, we could talk more about it for final exam grade. If you take the test, you don't just get like 100 for a final exam. So if we talk about that and you want to be exempt from the final, we can then talk about what each grade would be equivalent to. For example, if you get like a 3 or a 4, what would that be as a percent of the final exam? We'll talk about how to do that. Okay, and I'll give you guys the option. I'll give you guys the option to think about that. The only issue becomes the AP exam grade does not necessarily come in before the end of the year. So you have to think about what that would be. I'll talk more about it in a little bit. But for now, don't worry about, grade for the class. Worry about the AP exam. That's the important part. Okay? Let's try. What was that? Sounded like a.
Chime.
Not even a chime,
I'm trying.
yeah, the little
They're bringing up the
frequency bars.
Nope.
I
What?
think I could bring it the diners.
They're these little things, they're little bars that have a certain frequency. You tap them, they bring in a certain pitch.
Time.
It's to test your pitch. It's not a chime though. Chimes are instruments. I just give you. These are actual tools. They're little pitchforks. Frequency pitchforks. You hit the pitchfork and it gives a certain
Oh,
frequency.
I've seen those.
Couldn't think of the word pitchfork. All right. Let's do one more example to end, please. Let's do one more before we stop for today.
Right? I'm just gonna take 10 minutes break, then I'm coming back to Mr. Alex. Why can't we just stop class right now? Just practice.
That just makes you remedy.
Yeah, carry shot.
I just want to do that for you.
I could have been you doing that.
You should wait for the answer.
You should be.
When people presented with me.
Is that an X?
Why?
Is that a Y or is that?
Why?
Why?
No, I think it's like a messed up road.
I mean, you are
See, you never tell me.
Now, this one looks really confusing right away, and that's the reason I picked it. Okay?
All your numbers.
The reason I picked this is because it looks very confusing. But quickly look at the two different things that are multiplying. Is one of them the derivative of the other?
Yeah.
Or close to it at least?
Yeah.
Right? Take a look carefully and see about this. If I look at this one, take the derivative of this. The 1 drops off, doesn't it?
Yes.
What does the y to the 4th become?
4y.
4y cubed. Kind of like the y cubed?
Yeah.
What does the 4y squared become?
8y.
Kind of like a 2y?
How's that?
Okay?
Like
Kind of. I know it's a little bit weird. So if we do that though, we're going to notice it doesn't work out exactly, so we have to do some algebraic manipulation. Okay? We have to do something there. So let's start by saying u equals that entire trinomial up here. Okay? The entire trinomial. Because when I take its derivative, that derivative will probably cancel with what's up here.
Probably.
Because the derivatives are similar.
So when you pick u, you think of its derivative?
Correct. Whenever you pick u, think of its derivative, if its derivative would cancel with this, assuming it's a product, Christian. If it's a quotient, it's different. Okay? So du, dy, not x, remember you're doing y's now, doesn't matter, same thing. Du dy is 4y cubed plus 8y. No, nothing at the end for the 1, obviously. Please go ahead and solve.
I see why you said they probably cancel.
Solve for your dy here.
They cancel variables. Yeah, like the variable too. Because they're binomial. Because the trinomial, what it means is that trinomial will end up being a binomial.
Okay?
Cancel out the 8 too with the 8 in front.
We'll try and simplify. We'll look at that. Yep, it's a good reason it's there.
But you can't. Can you multiply the square first?
We'll find out.
Let's find out. Let's find out. Take a look at dy now.
Yeah.
Take a look at this right here. In your mind, everybody, multiply this by 4 right here. What do you get?
You get this new answer as that.
You get that, don't you?
Yeah.
Multiply this by 4, you get that. So when I substitute this in, maybe factoring out a 4 here will help me cancel my factors. So remember Algebra 2, you learned about GCFs?
Yeah.
What's the GCF here is just 4.
4y.
Well, 4y in this case, but it happens to have a y in both of those also. Okay, numerically speaking, yes, you're right. So now let's go ahead and plug in. Let's plug this in up here, and let's plug in a u for that entire function.
Yeah.
Okay, so this becomes the integral of 8u, again, that whole thing is u now,
Square.
okay, squared, thank you, 8u squared times y cubed plus 2y times du over 4 parentheses y cubed plus 2y. Again, why did I do that? So they cancel. That's why the 4 came out there. Again, this right here can really be written as 4y cubed plus 2y. The same thing that's up there. Now they conveniently cancel.
Yeah. Yeah, we just.
And there's no, I don't care about the number 4. The number 4 can remain there. That's fine. As long as there's no y's or x's or whatever else is there.
They can cancel out anyway.
And again, 8 over 4 is just 2. So this is the integral of 2u squared du. That's all this is, really.
2/3.
Again, take a look back. The 8 over the 4 becomes a 2. These canceled. We're pretty much done.
2/3.
What is it?
2/3 u cubed.
Good, because it's really u cubed over 3, but there's the 2 in the front. If you want to factor out the 2, because some people like to see that a little bit easier, instead of doing that, you can always factor out the 2 first. It doesn't matter, though. These are the same things here, because now if you integrate, you get u cubed over 3 plus c with a 2 out in front. Well, that's just going to become the 2/3 that we said. Okay, so either integrate here and just get 2/3 u cubed, or integrate there. The last thing is to do what?
Plug it back in.
Good. Make sure you plug back in, please. And you know what I'm going to do actually to make this easier? I'm just going to write 2/3 as a coefficient of the whole trinomial. I'm going to make the 2/3, I'm going to bring those in front, and then I'm going to plug in for my u cubed, my u value, y4, 4y squared, and 1.
Plus c.
Okay, plus c on the end. Now, to finish this, that's my final answer. If I give you a particular solution now, though, if I told you that this was a function of y, okay, and I tell you that f of zero, initial condition, f of 0 turns out to be 4. Now please find c. Same thing we did before. I'm telling you that f of 0 is equal to 4. And this is a function of y, not a function of x. Go ahead and try and figure out the value of c, please, to get the particular solution. Again, you're given an initial condition. Plug the initial condition in. Try and find your c value there.
10/3.
Where you get 10/3 is coming?
You have,
Yep.
you have 4 over it.
Check, yeah.
Yeah.
Looks good. Everybody, please notice right away, the 0 does what to this? Makes it a lot easier.
Y.
When you plug in the 0, those drop off, don't
Big
they?
1.
Okay, put a 0 here and put a 0 there. So you're left with 2/3. What's 1 cubed? 1, so it's just 2/3. Plus c equals 4, because that was the 4 given on the side. So I want to get rid of this, so I need to subtract 2/3. 4/3 is really 12/3, right? Is it 4/3? Sorry, 4/3. Is it 4 really just 12/3? So I'm thinking of this, and Kenny was right. If you subtract the 2/3, you end up with c equals 10/3. So your final answer would be this whole thing written this way.
That's 10/3.
I hate rewriting and putting it back in. Like the tedious step.
Okay, that would be the actual value of it. Okay, this would be, sorry, f of y. Okay, that would be the function itself. So we use u substitution when we have limits, when we don't have limits, when we have conditions. Now, please notice, guys, for your homework, you've already seen this already before, but if you want to see what it is, just for tonight, if you want to write it down, if you don't feel like looking, come on, where is calculus? There it is. The homework for this section is very, very intense. It's not an easy one, I'm telling you now. And there are a lot of problems here. So it's section 6.2. Okay, it's this entire part right here. Some of them, can't highlight it, some of them give you the u value to use. Do those first for your first practice tonight, please. Again, some of them tell you what to use for u, even though we've been figuring it out ourselves. The other ones don't tell you what u is, and you have to figure those out. You don't have to do every one of them, but please try a good amount. The ones toward the end are practice AP problems they put at the end of the section. They're just the multiple choice ones. Okay, so again, you have 2 nights, please. Make sure you get to this work. Don't just ignore it. You're not going to get better at this topic, and I'm telling you now. It's only going to get harder if you don't practice this. We're going to use u substitution. We're going to use it later when we get to this other stuff here. This is what's left for the year, really, guys, just so you know. 1, 2, 3 topics. That's it. We're pretty much done for the year already. Okay, we have 3 things left to do. We did this already, even though it's in the next section with distance and displacement. We did initial conditions. We did the average value stuff. So we're pretty much done with integrals. We still have to get to the application soon. Okay, so when we come back on Thursday, let's talk about our schedule for the next few weeks. So what you need to do tonight and tomorrow night is to focus on substitution. If you need to make up any of those concepts, I'll try and have them. I should have them graded by Thursday. If you want to see what the grades are. As soon as Karen and Kimberly make up what you need to make up from last week, I'll give them back to you so you can actually see them. Okay, any questions? Okay, have a great day, guys. Thanks for coming in.